Hey everybody, this is Mark Smith, the host of Digital Roughnecks, and I'm here with my co-host, David Conley.
Hey.
Hey, and we're here with special guest, Mark Fishburn from FLIR, and we're here to talk about how to continuously monitor for VOC gases without hiring a bigger LDAR team. So this particular thing came up, and we've been following regulation, this SB 181 in Colorado for quite some time. And a brand new regulation of SB 181, Regulation 7, Part 6, just got voted in recently. And what it requires is continuous VOC gas detection. You got to start 10 days prior to drilling, and then all the way through pre-production. And then it includes continuous gas detection through the first 6 months of production. And it goes into effect May 1st. But operators need to actually start looking at this right now because it impacts all the permits. All the new permits are going to have a plan, an emission plan about how you're going to implement continuous leak detection. Okay, so this is a big deal because the current regulation, if you're within 1,500 feet or anywhere near an urban area, you're checking for leaks every 30 days. And actually in pre-production, a lot of it was voluntary up till now, okay?
Yeah.
So that it's a big change, okay? So one of the things that the current method that is the 90% of the people use is the FLIR handheld camera, okay? So of course we talked to Mark here because this is his baby here. He sells a lot of these cameras. And we said, okay, we need to learn everything we can about how it's currently done so that we can figure out a method for how we could do it from, every 30 days with a human to continuously using AI. So Mark, you came back and you recommended the G300. Why and what's the similarity and differences with these two cameras?
Yeah, thanks, Mark. So the go-to camera out there that they're using while they're walking around the pad sites and doing their inspections is the GF or the GFX 320, and that's already approved through the regulations as an OGI camera. So what we're doing is we're trying to go to a fixed mount or a 24/7 type monitoring. So the G300a on the left here of the screen is basically a stripped down version of the GF 320. That's what the inside of that 1980s VHS looking camera is. And the reason that camera has that shape and form factor is because it's a cooled camera. There's a cooler running inside there. Think liquid nitrogen, bringing the temperature down to a negative 300 F. And that's how we're seeing gas. So unlike our first episode where we're using the Alara to basic IR to see tank levels, we're now using a camera with an extra filter in it to be able to see VOCs, methane, benzene, propene, all the anes and enes that we're seeing in the handheld camera, we're also seeing in the fixed mount camera.
Okay, so then David, you had the task
Sure.
of taking this fixed mount camera and testing it out with the AI software on a real, operator's pad. So tell me, so I'm going to play this video and you kind of tell me what we're looking at.
Yeah, so we're looking at the G300a about 40 feet in the air. The leak that you're seeing is a simulated controlled leak at 34 PSI. And it is about 150 to 200 feet away from the camera right now. So we're getting significant distance with the camera itself to actually span a lot of area, much more than we originally expected. Whenever we first started these tests, we were actually 30 feet away, which is about what a handheld would. I mean, a handheld's going to see this too, I believe. But the difference is this can be outside. We put it in a weatherized pan and tilt unit, so we can actually look around and make sure that nothing's leaking. It covers more distance that way. And we also put it in a housing that we can add a purge and pressure system to. I know a big question I get a lot is what about negative 40 degrees or extreme weather conditions? So we've factored that in and engineered that into the final solution to pair that with this camera. But the real magic is happening with that cryogenically cooled core. And something I did want to ask Mark about, just kind of while we're here, is one thing I've heard is, why can't we do this with a thermal camera? Why can't we if the weather's right, or we see there's a big cut of methane and a leak, you can pick it up in maybe the long wave. But why is this so important? Why is it so important for it to be filtered the way it is and cryogenically cooled core? Can you explain the difference between the thermal images and why it's important that we
I'll try to keep this as simple as possible. So in that Alara camera that we're using for the tank levels, it's a long wave camera, and it's covering a broad spectrum from about 8 microns up to about 14. In this gas detection camera, we're actually in the mid wave, so between 2 and 7-ish, 2 and 8, and we're filtering it even deeper. So whether you believe divinely or coincidentally, about 400 of the anes and the enes, the carbon chain, the methanes, all fall at about 3.3 micron. And that's exactly what that cooler and that lens is doing, is it's taking the mid-wave, filtering it again in that 3.3 micron for us to be able to see gas.
Right. Okay. Yeah. And that's an important part of actually meeting the demand that our political environment is putting us in, and it's really important to actually be able to say, yeah, no, if it's leaking, we're going to see it regardless. And that's why you have to have these cameras. It's not something you can really, get around in my as I've tested these and gone through a lot of different scenarios. So yeah, that's kind of how the testing went, and on the product development side.
Yeah, and we're going to be continually, in future episodes of Digital Roughnecks, we'll be talking about the progress as we get our algorithm better and better into different scenarios. So we do have if you'd like more information, we do have a free guide and video walkthrough called 3 Steps to Automating Your Pad Operations. And in one of those areas that we talked to right away, we solved another problem, because I think one of the reasons that people ask you, why can't I do this with thermal camera, is there's a significant cost difference between like the Alara FB we use for tank and the OGI camera, right? Big. And so that becomes a stumbling block. But actually, FLIR came out with a whole nother way of buying this, a camera as a service, which is, a very, very cutting edge way of doing it. It's basically eliminate the CapEx, eliminate the hassle of having to figure it out. So that's a unique thing that I think Clean Connect provides too. So
absolutely. Yep.
Absolutely. And we will outline that. You get all that information in the 3 Steps to Automating Your Pad Operations. So if you do sign up, you are also eligible for this FLIR C5. So Mark, tell me about this C5.
Yeah, great little tool. It's a camera that is the size of your cell phone, so that it could fit in your pocket, back pocket, front pocket, or just throw it in your toolkit or truck. This is a long wave camera, just like the Alara, except for handheld. So you can do tank levels with it. You could do electrical, solar panels, just a quick tool to grab and check things out, do some QC or some preliminary looks. It's Wi-Fiable, so if you had somebody standing next to you and with a iPad with a bigger screen, and you wanted to show a problem, you could flip it over to that screen as well. So just a great little tool for the price.
Right. So you can actually go to digitalroughnecks.com/FLIR, and you get to sign up for the free automation guide and be entered to win the FLIR C5. So guys, super thankful. This is part 2 in a 3-part series about how to choose the right camera. And I want to thank you guys for being here. And what's great is you're actually getting to see what happens a lot behind the scenes when David runs into a problem. First, he calls up FLIR and says, hey, what camera should I use for this thing? And so that's part of what this series is, just a little taste of what we're doing in real life. Okay. This interaction we're having here. So, hey, in the next episode, we're going to be talking about a brand new opportunity around liquid leak detection. So look forward to seeing you on the next episode.